Now in example 2, say we want to find the Thevenin equivalent for the same circuit, but this time using superposition. We recall with superposition that if we have independent sources, we will look at the contribution of each independent source independently, such that we can determine pertinent quantities, such as their open circuit voltage and short circuit current. That is, we'll start with the voltage source, and to do such, we will open the current source. By opening the current source, our open circuit voltage is the voltage potential established across a 200 ohm resistor, which is simply found by voltage division. Therefore, our open circuit voltage, or VAB, due to our 125 volt source is equal to 200 ohms per 250 ohms times our source voltage, 125 volts, which is equal to 100 volts. Now to determine our short circuit current, all we have to do is short terminals A and B. And in doing such, no current will flow through our 200 ohm resistor, rather all the current will flow through our 50 ohm resistor. Thus, we can determine ISC due to our 125 volt source simply via Ohm's law, such that ISC is equal to our source voltage 125 volts per the only resistor it will encounter, 50 ohms, which gives us a value of 2.5 amps. Now, we have to find VOC and ISC due to our current source, and to do such, we will short our voltage source. In doing such, we recognize now that we have a 50 ohm resistor in parallel with our 200 ohm resistor. To determine the current running through our 200 ohm resistor, we will employ current division. We note the current flowing through our 200 ohm resistor will cause a voltage drop that is opposite of VOC. Now, VOC due to our 2 amp current source is equal to the negative of 50 ohms per 250 ohms times 2 amps times 200 ohms, which gives us a value of minus 80 volts. To determine our short circuit current, we will simply short terminals A and B, and we recognize the current exiting our 2 amp source will flow from terminal B to terminal A through our short, such that ISC is equal to minus 2 amps. Lastly, we will sum the individual contributions from each of our sources. Thus, our open circuit voltage is equal to that produced by our 125 volt source plus that produced by our 2 amp source, which gives us a value of 20 volts. Our short circuit current is that produced by our 125 volt source plus that from our 2 amp source, giving us a value of 0.5 amps. We see this is the same value that we determined using NVA.